Now that we have an icy snow level, let's make it actually feel icy and snowy so that our characters kind of slipping around and not getting that same feeling that they're getting on the grass. To do that, we're going to need to go modify our player script and make it a little bit aware of what it's on and maybe control the way that our character is moving a little bit more tightly. So we're going to open up our player script and we're going to find our movement code, which is inside of our update method. We do our update grounding and then we read our horizontal input into this horizontal value. I want to rename this value now. I think that horizontal is something that we're going to need to keep track of, but I want to use the horizontal value not necessarily as the input or from the input, but I want to keep track of it, the actual value that we're using. So instead of having this underscore horizontal equals input.get axis horizontal, I'm going to double click on horizontal here and I'm going to say var horizontal input. And I'm going to make a temporary variable and we're just going to keep horizontal around as its own variable. Remember, if I hit F12 on it, it's a float that exists inside of our class. So it just kind of sits here and we can use it every frame or however we want, but we're no longer assigning it to the input. Now that's assigned to this horizontal input variable instead. And now what I want to do is move our horizontal value from our current horizontal value towards the value that I actually want to be at. So we're going to figure out a desired velocity and then use a math formula or a math calculation to go from that our current velocity to that desired one. We're going to add in a line here on 69 and say var desired horizontal. Did I spell it right? Yep, equals, and we're going to use our horizontal input times our horizontal velocity, which is our horizontal max speed actually. In fact, we're going to rename this now. So with horizontal velocity selected, I'm going to hit Control R, or F2. That's also a rename button. And I'm going to call this max speed. Or let's call it max horizontal speed. There we go. So now we've got a max horizontal speed in our horizontal input, and we've got a desired horizontal, this is our desired velocity along that x axis. So our desired horizontal is there, and our current is right now getting multiplied by max horizontal. That's not what we want at all. Instead, what we want to do is assign our current horizontal value to be equal to, so say equals, and we're going to use mathf.lerp. This is a linear interpolation, which is going to go from one value to another over some amount of time. So we're going to give it our starting value, which is the current horizontal value. And then we'll give it a comma and the desired horizontal value as the ending value or the target value. And then finally, we'll give it an amount of time. And for that, we're going to use our time dot delta time, and then we're going to give it some sort of acceleration value. So we're going to do times underscore acceleration. I'm going to go to the end and add a semicolon, and then we'll generate a field for our acceleration. So I'll hit Alt Enter with acceleration selected, allow it to generate a field, hit F12, replace private with serialized field. Add that square brace, and then I'm going to move this line. So I'll select the line 23, cut it with Control X, go up here to line 11, hit Enter and paste, and let's give our acceleration a default of 1. So we've got an acceleration of 1, and now inside of our movement code, let's go find that again. Where are you, movement code? We no longer do the old calculation of just multiplying our horizontal velocity and then setting our rigid body velocity to it. Instead, we set our horizontal velocity to our current value lerped to some new value. Now let's talk a little bit about what this mathf.lerp method is actually doing. So when you call this method, you pass in a beginning value and an ending value. Let's say we passed in a 0 for horizontal and a 100 for desired horizontal. Totally made up numbers. Let's just imagine them for a moment. The last value that we pass in is a percentage from 0% to 100%, or how far along between those two values we want. So if I had a 0 for the horizontal and a 100 for the desired horizontal, and I pass in a 0.5 or a 50%, I'm going to get back a value of 50 because that's in between 0 and 100. Now, if I had a value of say negative 100 and positive 100 here. Maybe I was going all the way to the left super fast, 100 meters, and my desired is 100 meters to the right, and I put in a value of 0.5. Well, the value in between there, right in the middle, would be 0. If I put in a value of 1, the value that I would get back would be a positive 50. And if I put in a value of negative 1 here, I would get a negative 50. So negative 1, or a 0 will get you the first value. A 1 here will get you the second value. And a value in between 0 and 1 will get you some number in between the first and second value. So this is going to slowly accelerate or decelerate us, multiplied by some acceleration value, so we have total control over it. Let's go back into our game, press play, and watch our acceleration on this icy level and see how it feels. There we go. You can see my character kind of doing that little slip there. And if I adjust this acceleration down to like a 0.5, you'll see that they slip quite a bit more. They'll go for quite a while, and it takes a little while to speed up and get going the direction that you want to go. That's the feeling that I want here. Now, if I crank this up to like a 20, then you'll see that I've got nice snappy movement just like I had before. I can control it exactly how I want. Now I want to do two little changes here. First, I want to stop playing and I want to crank up my maximum horizontal speed. I had it at 3. I think a 5 might seem a little bit better. So let's save. Actually, let's go to our player script and let's change the default value of that to 5 as well. So we'll set it max horizontal speed to 5. Go back into Unity. Play, and I want to jump around, make sure that it feels good. And then let's figure out a number that we're going to want for when we're not on the ice. Because right now, notice that we're slipping around no matter what surface we're on. We didn't do anything to check the surface. We just made it so that our character slips around. So let's set it to, we've got a max horizontal speed of 5. And right now an acceleration of 1. Let's see what that feels like. Ooh, yeah, that's kind of good and slippery. I feel like this could go down to maybe even a 0.5 though on the ice. Let's see. No, let's go to a 1. So a 1 on the ice seems good. I felt it. It felt a little too slippery. And then maybe let's try a 10. Yeah, something like that. Like a 10 or maybe even higher on non-ice surfaces, I think would be good. I don't have a way to do that right now though, so we're going to stop playing. We're going to leave it at 1, or let's crank it up to 10 actually. We'll save, and then we're going to go into plastic. And actually, let's go to our player script before we do this. We'll go to our player script. We'll change the default acceleration to be 10 as well. And then we'll go back into plastic. And we'll commit and say that we've added acceleration controls to our player. And we're done this so that we can control it with the iciness effect, or so we can add an iciness effect. So let's say added acceleration controls to the player. And we'll check in our changes.